In this video, we're going to talk about even and odd functions and even and odd properties of the trig functions. And when you think back to your college algebra class, a function is even if you plug in the opposite sign for your input, but you still get out the same output no matter if you plug in the positive or the negative of that input. So you would get the same output no matter whether you plug in a negative input or a positive input. And this tells us it's symmetric about the y-axis, meaning if your coordinate plane was a piece of paper and you folded it over on your y-axis, it would look like a mirror image on either side of that fold. An odd function, if you recall, is when you plug in the opposite sign of your input and you get out the opposite sign of your output. So the sign of your output switches if you put in the opposite sign of your input. And when this happens, it's symmetric about the origin. And if you picture that would be if your coordinate plane was a piece of paper and you fold it over on your x-axis and your y-axis, you fold it twice, then it's going to be a mirror image when you fold it over on those creases. With that, we're going to discuss the even and odd properties of trig functions. Now, we haven't talked about the graphs of trig functions yet, and so you'll be able to verify this when we go over the graphs of trig functions, and you can visually see this. So as of right now, that's an IOU, but for right now, I just want you to know which trig functions are even and which trig functions are odd. The even trig functions are cosine and secant. So that means if I plug in the opposite sign of my input, I'm going to get the same thing out whether I plug in the positive value or the negative value. I'm going to get the same value for my output. My odd functions are all the other trig functions: sine, cosecant, tangent, and cotangent. Cosine and secant are the only even trig functions. So if I plug in for the other four trig functions, whether it's sine, cosecant, tangent, or cotangent, if I plug in a negative angle or the opposite sign of an angle, that is going to switch the sign of my output as well. We can use this to our advantage to evaluate trig functions with negative angles. So for example, in part A, it says find the tangent of negative pi over 4. Well, if I look at my unit circle, the tangent of pi over 4 is going to be 1, because I know that the tangent is the sine of pi over 4 over the cosine of pi over 4. And since they're both the square root of 2 over 2, I'm going to get out 1. Now, since tangent is an odd function, that means if I switch the sign of my input, that's going to swap the sign of my output. So tangent of negative pi over 4 is going to be negative 1. And that is because tangent of negative pi over 4 is equal to negative tangent of pi over 4. If I look at cosecant of negative pi over 4, cosecant is also an odd function. So that means this is going to be equal to negative cosecant of pi over 4. Whatever my value is for cosecant of pi over 4, I just take the opposite sign of that. Cosecant of pi over 4 is the reciprocal of sine of pi over 4. Since pi over 4 is the square root of 2 over 2, then cosecant of pi over 4 is going to be 2 over the square root of 2, which if I rationalize that will just be the square root of 2. So that means cosecant of negative pi over 4 will be the opposite of cosecant pi over 4, which would be negative square root of 2. Cosine of negative pi over 4, because cosine is an even function, I'm going to get the same value out for cosine of pi over 4, whether I put in a negative or a positive there for my angle. And since cosine of pi over 4 is the square root of 2 over 2, I also know that cosine of negative pi over 4 is the square root of 2 over 2. So for even functions, you're going to get the same output whether you plug in negative angle or positive angle. So if I plug in negative 30 degrees or positive 30 degrees for cosine and secant, I'm going to get the same value back. But for odd functions, if I switch the sign of my angle, I'm going to switch the sign of my output as well. So in these next 3 examples, A, B, and C, we are going to actually determine if the function is even, odd, or neither. So thinking back, a function is even if I replace x with negative x, and I get out the same value of the function. So whether I plug in a positive value of x or the negative value for x, I'm still going to get out the same value of the function. If it's odd, then when I replace x with negative x, it's going to switch the sign of my output. So we're going to take all of these examples, A, B, and C, replace my x's with negative x's, and then check the result to make our decision. So in example A, I'm going to replace all my x's with negative x's. Negative x squared is still going to give me x squared because x is going to become a positive, right? Negative x times negative x is a positive x squared. Sine of negative x, if you look at your shaded box up at the top, we can see that sine is an odd function. If I replace x with a negative x, I'm going to get out the opposite value of my function. I'm going to get negative sine x. Now, if I clean this up a little bit and pull that negative 1 in front, this x squared sine x is my value for f of x. So when I put in negative x for my f, for my function, I'm going to get out negative f of x. That tells me that this function is odd. I switch the sign of my input and it switches the sign of my output. Looking at example B, I'm going to replace my x with negative x. If I take the absolute value of negative x, that's still going to be equivalent to absolute value of positive x. Those are the same. Cosine of negative x is still equivalent to cosine of x because cosine of x is an even function. So if I replace my input, or I switch the sign of my input, I'm going to still get out the same value of my function. And you can check that up in the shaded box. So if I plug in negative x, I'm still going to get out the same thing I started with, g of x. So that means this function is even. The last example, I'm going to replace all my x's with negative x. Negative x to the third means negative x times negative x times negative x, which is negative x to the third. Cosine of negative x is equivalent to cosine x. This is not equal to h of x and is not equal to negative h of x. Negative h of x would be if I switched everything, right? Negative h of x, if you look up here, would be if I switch the sign of all of it. So the negative would be in front of the x to the third, and the negative would be in front of the cosine. So this is an example where you would have that it's neither even or odd.